Okay, I'm gonna do a little bit of a review. Did you have a question? I'm just stretching. Okay, I just drew a little picture here. If I asked you to take this picture and reflect it over the x-axis, what would you do?
Change the X values.
Y
My
values.
bad.
You would take your ordered pairs, which, let's make a t-chart of them. What are they? What's this one? Can you guys see it okay? 0, 3,
3,
3, 3,
5, 7.
and 7, 5. So, if I wanted to reflect this over the x-axis, what you do is you take all of your, what?
Y values and change the
Y
sign.
values and you change them. You keep your x's the same, right?
Yeah.
Yes.
And in the problem, that turns the C value negative too, right?
The c value?
Yeah,
What c value?
the C value in the
You're talking about an equation?
Yeah.
Yes.
Okay.
Yes, you're talking about what we did in 3.4
4.
transformations, yes, the number in front. That is a reflection over the x-axis, yes. Okay, so we're just looking at this picture right here. If I wanted to reflect this over the x-axis, I would end up graphing 0, -3, 3, -3, 5, -5,
And 7 negative.
and 7, -5. And you carefully draw your picture. And that's what you get, correct? Now, when we had an equation and we wanted to reflect this over the x-axis, what did you do? When you had an equation, what would you do?
Negative.
What did you change here? What did you change here? You took the y values, and what did you do with them? You made them the opposite. What if we wanted to take this picture and reflect it over the y-axis?
Change the x's.
You take these ordered pairs, so to reflect
Y-axis.
over the y-axis, you take these same ordered pairs and you're going to change x and make it the opposite. What's it going to look like?
0
It's going to be going this way.
over.
Correct?
Yeah.
Okay. What if we wanted to take this picture and reflect it over the origin? What would we do?
Y would be a
Reflect
opposite.
over the origin. What would we do?
Both change.
Both of them. And so you're going to take all of these ordered pairs and you're going to graph 0, -3. You're going to graph -3, -3. You're going to graph -5, -5, and -7, -5. Okay? This is a little review of section 3.4a, symmetry. So we have symmetry to the x-axis. We have symmetry to the y-axis. So in other words, if you folded this along the x-axis, if this piece matched this piece, you would say yes. If you were testing for symmetry on the y-axis, you fold this on the y-axis, and if this piece matches this piece, yes. In the origin, what you would do is look at your X and your Y's, and they should be, for every ordered pair that's on there, if you changed them to be the opposite, then you would say yes. Okay? So far, so good. Now in section 3.6, we're gonna do another type of symmetry. It's called symmetry to the line y equals x. Do you guys know where the line y equals x is? You guys know where y equals x is? How do you graph y equals x?
Up one over one, one lower middle.
Where's the y-intercept? Here it is, and the slope is 1. Okay, now, I am not going to connect these dots because it's not part of my graph. So if I took something, I'm gonna do something different. Let's do that. If I wanted to reflect this over this line, do you have an idea of where it would be? So in other words, if I folded this on that line, and here's a little fun thing you could do. If you took a pencil and you darken this, you ever do this before in geometry? You did that? Okay, and then if you folded this carefully, it's kind of tricky to do this perfectly, but what you're supposed to do is do that, and you'd kind of see it. Sometimes it shows up depending on how dark you put the lead on that picture. Okay, you would see a reflection. You'd have to do it really carefully, but that's not what we're gonna do. That's something you'd probably do if you were in middle school. What we're gonna do to reflect something over this line, you're gonna take these ordered pairs, let's name them. This is 0, 4. This one is 2, 4. And then we have 2, 3, 4, 5, 6, 7. And we're gonna do 4, 9. When you reflect this over this line, what you're gonna do is switch your X and your Y. So in other words, see this ordered pair? If we wanted to flip this over this line, you're gonna graph instead of 0, 4, you're gonna graph 4, 0. 1, 2, 3, 4, 0. Okay, how about this point? This is 2, 4, what are you gonna graph?
4, 2.
4, 2, which is right here. So I'm gonna start connecting my dots in order. Instead of 4, 7, what are you gonna do?
7, 4.
And if you see it, I don't know if you can see this, but
Yeah, I can see it.
you can see it kind of in the last one.
9, 4.
So we have 7, 8, 9, 1, 2, 3. How about that? So this is a reflection over this line. So how do you reflect something over the line y equals x? What you do is you take your x values and you make them your y values, and then you take your y values and you make them your x values. This has another name. It's called the inverse. This has a special name. So the inverse is when you switch x and y around. So if you look at this first on your notes, everyone have the notes? See that picture right there? What is it? Example 1. Anyone recall what this is? Yes.
Thank you.
This is a quadratic function. It's actually the parent function. okay? I'm gonna put it on graph paper.
Extra second.
So here it is, it's 0, 0, then we have 1, negative 1, 1, and we have 2, 1, 2, 3, 4, and I'm gonna stop there because you have it. So if we wanted to take this, which it's a function, we can write it like this. If I wanted to take this and graph its inverse, all I'd have to do is take these ordered pairs and reverse them. So 0, 0, if I take 0, 0 and switch them, I still get 0, 0. How about this ordered pair? 1, 1,
Stays the same.
it's gonna stay the same. But what about negative 1, 1? It's gonna be 1, negative 1. So this point is actually this point when we do the inverse. So these two stayed the same. How about this one? This is 4, 2. So we're gonna graph 2, 1, 2, 3, 4.
That's 2, 4, you're gonna go 14.
I'm sorry. Thank you, Jordan. My mind is ahead of myself. So 2, 4, you're gonna graph 1, 2, 3, 4, 1, 2. So these two, and imagine your line y equals x going right through here. I didn't draw it, but can you imagine it? Does this look like it's reflected over that line?
Yeah.
It should. And where do you think this one's gonna be?
Negative 2, 4.
So this is negative 2, 4. So we're gonna graph 4, 1, 2, 3, 4, 1, 2. So we're not switching signs on any of these. You have to get all of the 4 different symmetry problems straight in your head. And now we want the same shape. So don't turn this, it's a U-shaped figure. Don't turn it into something else. It has to stay a U-shaped figure. And there it is. Is everybody good with this?
Yes.
Very easy. So, to recap, how do you take the inverse of something? You just switch the ordered pairs around. Okay? Now, look at this problem, the original problem. It's y equals x squared. Actually, it was f of x. Why do we write f of x? Do you guys know why we write f of x?
There's no point in x.
This is a relation. It's a relation, right? We're relating x and y. And it's a special type of a relation. For every x, there's only one y. So it's a function. When we have a relation and it's a special kind of a relation where for every x, there's only one y. In other words, none of the x values ever repeat. Okay? So when that happens, you have a function and you can use that fancy f. Right?
Mm-hmm.
So, this is a function, but look at the inverse. Is the inverse a function?
No.
No. So on some of these problems, you cannot use this fancy f when you do the inverse. Okay? How would you rewrite this equation? How would you write the inverse of this? Anyone have an idea? So, do you agree that this y equals x squared is the equation of all the ordered pairs in red? Do you agree? How do you think you're going to find the equation of this one? Whatever you did to your ordered pairs, you do to this equation. So what are you going to do now? Anyone have an idea?
Square root.
Switch x and
Negative x.
Say it again, I heard it.
switch x and
You're going to switch x and y. You're going to take this equation and you have to now replace, so where you see an x, you're going to switch it for, or a y, you're going to switch for x, and this one you're going to put a y. So do you remember when we did symmetry problems and it said, take this equation and rewrite it, do it algebraically, make it symmetrical to the x-axis. Do you remember what you did in section 3.4a? In 3.4a, when you had an equation and it said make this algebraically symmetrical to the x-axis, what did you do with that equation? Because you have to do this on your test. Please remember.
Say it again.
Say it again. If I make an equation, do I need to pull out 3.4a notes?
What was the question? I didn't hear the question.
Yeah.
Say it again. Right here. See if you remember this. What did you do here on this problem? This was back 3.4a. I want to take this and I want to algebraically prove that it has symmetry to the x-axis. What am I going to do to this?
Fill in negative y.
Say it again.
Oh, line.
You're going to take your y and you're going to put negative y, right? And then when you do that, what do? Do you just leave it? You have to resolve it for what? Make sure it's solved for y, okay? So this one, after you replace the variables, so in other words, y becomes x, x becomes y, what are you gonna do? You're gonna leave it like this? No, you always resolve this for y. So what would I do next?
Square root.
Square root of both sides. Go ahead, I'm listening.
And then
Leave it.
y equals plus or minus the square root of x.
Now, do you remember on that last test, the very first two questions where it said, is this a function? Is it unique?
Yeah.
This is your inverse right here, guys.
That's not
This is this equation right here. This is this. You know why there's two plus? This piece is plus root x, and this is the minus part. Is this a function?
No.
No, because it's not unique. So, if this is not a function, can I put a fancy F here?
No.
No. You only have the right to put the fancy F if its inverse is a function. Okay? So, we can't do this. We're gonna just leave it like this. Just like that. So if you put f of x here, it will be incorrect, because it's not a function. Unless you restrict the domain. If you use only part of this, then you can. Now, what if I had something like y equals x plus 4? And it would probably be written like this. Okay, you know these are the same.
Flip y
Right?
x.
If I asked you to find the inverse of this, what would you do?
Flip y x.
So you'd have x equals y plus 4, and then what would you do?
Solve for y.
You're going to solve for y, so this goes over here.
Y equals x.
Now, imagine graphing this. This is y equals x minus 4. We can graph this, right? Check this out. This is the inverse of the line y equals x plus 4, which is right here. Okay? These happen to be parallel lines, but one is the inverse of the other.
And both
Now, I have a question for you. Was the original a function?
Yes,
Yes. Is the new one a function?
yes,
How do you know?
because it passes the vertical line test,
It passes the vertical line test.
and it's unique,
It's unique. Ken, we have a question for you. How are we gonna know, how is anyone gonna know that I took this, and this is the inverse of this? So now I wanna use function notation. If this is called f of x, I can't call this f of x too. There's a special notation for inverse. I can use the fancy f, but does anyone know what it looks like? Looks like this. It's an f. It looks like it's to the -1 power. So it looks, I'm gonna write it where the f is on the left side. It'll look like this.
I've seen that.
Okay? This is the notation you will use when you take a function and you find its inverse. You have to write this, guys. But you can only use this if your inverse ends up being a function. Okay? I want to look at a couple examples. We're going to talk about that. We're going to go into that a little bit more detail. I want you to look at example 3. If you were asked to sketch this graph, imagine in your head, where would you begin? At -2, right? And you'd go up 3 and over 1. Is this a function? Yes. And they also wrote f of x, right?
Yep.
So now, I want you to find the inverse of this. What would you do?
Plug in y for x and x for y.
Then what? This is where you're going to switch x and y.
3y minus
Now, you do not leave it like this. What do you have to do?
10. Solve for y.
Now you're going to solve for y. So this is, I'm going to write this the other way, reverse it.
I think I have to figure it
Plus
out.
2.
We're going to add 2, right?
Y x plus 2.
I have to put the x first. Then what? Am I doing it right, guys?
Yeah,
Now, is this a function?
yes,
It is. So we can't name it, we have to put the f in, the fancy f.
but it says g of x.
Or g, we could call it, we're gonna keep it f of x.
Oh, okay.
Forget that g of x. We wanna write, we wanna indicate, we're not gonna name it something else, g of x, we're gonna keep it f of x. But can I say f of x?
No, you have to have
No.
the inverse.
The notation looks like this. Okay? Now, there is another test. You guys, you looked at your ordered pairs, and you graphed it, and you did the vertical line test, right? To tell if the inverse is a function. I'm going to show you another way to tell if the inverse will be a function. Do you remember when we looked at T-charts? Okay. If I asked you, is this relation a function, what would you say?
No,
No? This relation, the way it is it a function?
no,
What was the trick we did when we had a bunch of ordered pairs?
you put a plus or minus in either spot and that's
But x doesn't repeat in here, so.
Say it again, say it again.
X doesn't repeat, so it isn't.
If the x value does not repeat, do you remember this? If the x value does not repeat, then it's a function, right? Well, let's say we had this picture right here. How do you know, and then I ask you to find its inverse.
Switch them.
Before you even switch them, don't even do that. What you're gonna do is if I ask you, is the inverse of this, when I invert this, will it be a function without doing it? What you're gonna do now is look at your y values. If any of your y values repeat, then it will not be a function. Okay, so it's switched, just like you switch the x and the y. That process, that thought process of look at your x column, if any of the x's are repeating, it's not a function. Well, now they're gonna ask you, here's a function, I wanna know, is its inverse gonna be a function? You're going to look at the y values, and if the y values repeat, you'll say its inverse would not be a function. What did we call the test when we drew lines through a graph? What was it called? It was a vertical line test. Guess what this is called now? Horizontal line test. So if you can draw a horizontal line through the function, the original function, if you can draw a horizontal line through it, and if it hits in two spots, its inverse will not be a function. Did you get that?
Yeah.
So, look at, I want you to go to these, and that's what this whole page talks about. It's talking about the horizontal line test. Now to speed up this process, here, look at example 5. I have 3 functions right here, f, g, and h, and they are nicely graphed for you at the bottom, so you don't have to grab a graphic calculator. So we took f of x, and you have this in front of you, it's graphed, and this is a picture of it. If I asked you to tell me, this is an easy question, will the inverse of f of x, will it be a function? Without going through the process of taking the ordered pairs and switching them, and then resolving it for y, this would be very tedious to do that, wouldn't you say? So, would you say yes or no? The inverse of this would be a function.
Yes.
Yes. Because when you draw a horizontal line through its the original function, it hits in only one spot. So yes. The answer would be yes. How about this one?
No.
No. Here's an example right here. So no on this one. If we were to take this and flip it over the line y equals x, or if we switch the x and the y in the equation and resolved it for y, no, this would not be a function. How about the last one? And
No.
I can understand if you say no, this is not meant to be, look at the equation, it's an x cubed, it's gonna look like this. It's like that.
Oh, okay.
No, look, it's like that one. I know, it looks flat right here. It's not meant to be flat. What's this answer?
Yeah.
This one, yes.
42.
So, when the function passes the horizontal line test, we will know, we will expect its inverse to also be a function, and we get to do this for this one and for this one. When we resolve it for y, we get to do that one. This one you can't. It's not to say you can't find the inverse of a function. It just doesn't get that that title to do that f of x or h of x or g of x. You can't put that -1 there. It's incorrect notation. I just want to make sure everybody understands that. Does everyone understand what I'm talking about? Okay, so here you go. Last example, example 7. This will probably be the most difficult question on your test. And the only reason why it's difficult is because of the algebra skills that you need to solve it. You might have to reach back in your mind and get this from algebra. Oh, I don't even know. Algebra 1 didn't spend too much time on this, so you're gonna have trouble with this one. Now, to prove, you have to know how to do this. You were supposed to do this in Algebra 2. It's the simplifying of fractions, and you'll see what I'm talking about in a minute. One way, I have two different functions. One's called f, one's called g.
42.
If I say, is f of x the inverse of g of x? So in other words, if I graphed f of x, would I get that equation? One way you could do it is you could replace x and y and then resolve it, and you'll see what happens. That's not what they want you to do. They want you to find the composition of these functions. In other words, and we just did this yesterday, you're going to do f of g of x. And if you can get, you're going to plug this in here, and you're going to simplify it. If you can get this to be x reduced to x, and you have to do g of f of x, so then you're going to take this and replace it for x's here and simplify it. If you get x in both of these, then you say yes, this is the inverse of this is the inverse of that. So let's do this. And I know I'm running out of time.
Yeah, you got it.
And the rest is your homework. So how would you write f of g of x? You would take this piece right here and you would plug it right there. So in other words, 5 over 2 times 4x plus 5 over 2x minus 4. Now imagine you have to get this to equal x. Do you know how to do this math right here? What would be the first thing you do? You want to simplify this. So you have 5 over, how do you incorporate this 2 with this fraction? Where do you distribute it?
To top.
Only to the top. So 2 times 4x is 8x plus 10 over 2x. Now remember, you have a minus 4 right here. Now what are you going to do? How do you combine these two fractions?
Find common denominator.
You got to get a common denominator, and this is what I'm talking about. So, I've got so far 5 over, can you do this in your head? What's 8x plus 10x minus 8x?
8x plus 10, just 10, not 10x.
8x plus 10, I'm sorry, 8x plus 10 minus 8x. It's going to be 10 over 2x. You're going to flip and multiply, and you're going to end up getting x. And now do this for this, and prove it, and here's your homework. Make sure you do it. Get all your homework done by tomorrow.